Hello, everybody. Dr. Charlton here. Today, we're going to learn a little bit more about R. So I'm looking forward to, helping you move a little bit along with that. We're also going to learn a little bit about statistics and about analyzing data. So hopefully, it'll be interesting for you. I know it might seem crazy, like the idea of writing code, but again, I'm going to give you the code. So it should, hopefully, if you just follow along and watch the video and then go to the lab, you should be able to pick it up pretty well. So first of all, I'm going to start with a blank document. So what I'm going to do is I'm going to create a new R script. So if you'll notice, down here at the bottom, I have an a console, and this is where we've been running our code, right? So I can do I can say like 5 plus 5, it's going to be 10. So we can run it right in the console. But another thing that we can do is do a fresh R script. So I went up to this new document thing here, clicked the down arrow and selected R script. So now I have an R script. So I could put 5 plus 5 here. And then if I hit enter, absolutely nothing happens. But if I select it and hit Control Enter, it runs. If I select it and hit run, it runs. Even if I'm just on the same line and I hit run, it runs, or if I hit Control Enter, either way, however you want to do it, there's several ways to make the code run. So the cool thing about this is, whereas in your console, once you run that code one time, that code is gone. When I put my code up here, it gets saved so that I can use it throughout my project. So for the homework, I'm going to give you the code that's on this document right here, but I'm going to go ahead and borrow from it. So the way I recommend importing this code for now would be just for you to copy whatever you need and then paste it into your document. So I'm going to do it a little bit at a time, starting with this right here. Okay, with just the getting started stuff. So let's see. I'm going to use a data set called air quality. You can see that up here. It's actually built into R. It's just like a toy data set so that people can learn how to use R. So it's just completely built in. It's already there with every R installation. I'm going to use a couple of libraries, a couple of packages. One is called tidyverse and one is called ggplot2. And tidyverse will help us kind of manipulate data so that we can kind of get the data in the form and format that makes sense for our analysis. And ggplot2 is data visualization, so it helps us make really cool graphs. So one of the things that R is really known for is giving people the ability to make the best graphs. So it has like the best data visualization tools, and so we're going to get into that a little bit today. So first of all, I've already installed these packages, but if you have not installed it, you want to go type in install.packages, and then you put the package name within the quotes. So for example, tidyverse, I'd put it in the quotes, and then you want to run that. Now that's a one-time thing, so I've already installed these in the past, so I wouldn't run that, but I'll just show you what it would look like. And if I do run it again, it won't hurt anything. It'll just be slow, and I'll have to wait for it to download and install, and I don't want to do that. But I would just run this code. Hopefully you can see that okay. Like I said, I'm not going to do that, but you can if you need to. So all I have to do is run these two lines, and when I run them both, then it loads that package into like the active memory. And so that takes up memory space. So if I didn't need these packages, I wouldn't be loading them. I would have them downloaded, but I wouldn't run the library function, because this library function, here, let me see if I can look up the tutorial. So when I do a question mark before it and the function name, so it loads and attaches add-on packages. Okay. So if you have an add-on package, which we do, we have these two packages because I already installed them in my case. You might need to install them, in which case you would use this code and insert the package name in here between the quotes. Keep the quotes and load your package name. I don't need that because I already have this. And you can see I loaded both these libraries. And if I check in packages, you'll see that ggplot2 is checked. And actually I could just check them right here too if I wanted to load a package. So I'll just, and then I have tidyverse is loaded. So any of these packages that I already have downloaded, I could just check them and load them. Let me see if I want to. I'm trying to be careful here about which one I check, but they should all be fine. Because having one of these or that you don't need loaded in memory probably won't hurt you. But imagine if I had all of these packages loaded in memory, how slow my machine would go. That's why I only run the library function for stuff that I need at that time. So if I do check this box, you can see it just installed the generics package, which I'm honestly not even familiar with. And then it tells you what the impact is because it has a name, a function name that conflicts with another package. And so it tells you how it's dealing with that. So anyway, that's how that works. All right, so now I'm ready to run some functions. So I'm gonna bring over all these summary functions. So I'm just gonna get to know my data set. So I'm gonna copy this and just bring it over here, paste it right here. So as it says, this is how you can get some summary data. So basically I have this data set, it's called air quality. And if I just run just air quality, it shows me everything that's saved with that variable name. So it gives me all the data. See? Sometimes it will truncate if there's too much data. It will say like 8,000 rows omitted or something. In this case, it just gives me all the data. This is the whole entire data set. But a lot of times you'll have a big data set, so you might want to just look at the first 6 rows. So if I want to just look at the first 6 rows, I can use this head function. So when I have this command right here, I actually don't know what that's called, but it's like a %. It's if I run this function and then I put in my function name, it's saying do this to this object before. Okay, so I'm gonna run the head function, and if I here, let me show you once again. I can do the ask it what the function is. And then it says it returns the first or last parts of vector. Since head and tail are generic functions, they may also have been extended to other classes. So return the first or last part. So head returns the first part. So if I run this row, and the one thing I want to point out too is like these green here with the pound symbol or hashtag as you might call it, will create a comment. So this stuff is not run as code, it's run as comments. So it means it means the R ignores it and just puts it as just like a comment is all, and there's no like functions or anything running. And all you can see, RStudio conveniently made all my comments look green. So their green stuff won't run. It won't do anything. It's just there for my information, and I could delete that all and it wouldn't change anything, or I could add more. So I just ran two commands. One was head, and it's going to show the first 6 rows, and one is tail, and it's going to show the last 6 rows. And this is like the actual data. So here's all my variables: ozone, solar.r, wind, temp, month, day. Those are all my variables. And this is my last 6 rows, which means my last 6 observations. So for every observation, you have a measurement of ozone, a measurement of solar.r, a measurement of wind, temp, month, and day. Okay. So on the top, I got variables, and then rows are observations. It'd be the same thing if I had, if I did, had everybody in the class and I had your birthday and your major, it would be like your birthday would be one variable. So they'd be these headers up here, and your major would be another variable, and where you did your internship, that's another variable. And so I could, those wouldn't be numerical variables, but they would still be variables that would have categorical data like words instead of numbers. So now I've looked at the first 6 rows. I've looked at the last 6 rows. Let's see what's next. All right, now I'm going to run this next row. This is the summary function. Now, if I do and I'm going to ask it what the summary function is. It's so basically just, okay, some of these are more helpful than others. One thing that's really helpful though about asking it about the function is it will tell you the arguments. So in this case, we don't really have arguments, but a lot of these functions will have a lot of arguments. So, well, does have some arguments. So that you can add it. Now we're not running any arguments. We're just running the bare summary function. So when I do that, you can see I get the min, the max, the median, the quantiles. So like the first quantile, that would mean like the 25th percentile is at 18, the median or 50th percentile is at 31.5, 75th percentile is the third quarter, that's at 63.25. And then very importantly, it tells you how many NAs you have in your data, which means how many missing entries. So when I'm looking at this, what's it called? The air quality data set, I noticed there's 37 rows where we don't have an entry for ozone. So if ozone is an important variable to us, we're missing a lot of data there. And I'm actually going to add in one more function. I'm going to do a view. I think that actually has to be capital view. So capitalization matters a lot in R. I'm going to view the whole data set. And then if you notice, I'm looking at the whole data set in this other tab, and you see all the NAs in here for solar.r. As I scroll down, there's a lot of NAs, and there's a lot for ozone. And so those NAs just mean there's no data. So it's not a zero, it's just a blank. That's what NA means, just a blank. All right. So there's a lot of NAs for these first two variables. All right. So basically I'm just running all these different functions. So head, look at the first 6 rows. Tail, look at the last 6 rows. View, look at all the data in a separate tab. Summary, that was the one where I showed you the min, max, and NAs for every variable. Last one I'm going to run is I want to look at the structure of the variables. So I'm going to run the str command function. So you can see I've got 6 variables, 153 observations, and they're all integers or numericals. Or numerical variables. So a numeric variable can be, it doesn't have to be an integer. It can be like point something, 7 point something. An integer is a round number. Numeric, in my experience, numeric and integer have always worked the same in all the types of data analysis that I've done. So I just consider them to be the same thing. Other people might have had a different experience somewhere where they had an issue, but to me, it's just the same thing. So it's interesting to know that they're all numeric, because what if I want to look, so later on, I'm going to look at the month as a category. I'm going to use the month as a category because I'm going to say, like, how does this differ by month? So when you want to say, how does it differ by month, all of a sudden, it's not, all of a sudden you want to categorize it by month. So I might need to change it to a different kind of variable. And actually, that's probably what I'm going to do next, I think. So yeah, I'm going to convert it to a factor. So I'm going to copy my next section of data, my next section of code. All right, let me see here. I convert the month to a factor. Okay. So basically what's happening is I'm going to do some stuff to the air quality data set. Okay. And then I'm going to save it as itself. So I'm going to overwrite what was previously there. So that's what this means. So I'm going to save air quality as air quality. Okay. But first, it's going to do this function to it. It's going to do the mutate function. Mutate is out of the tidyverse package that we installed earlier. What mutate is basically going to do, it's going to tweak whatever variables we want. So I have this month variable, which, as you saw, is an integer variable, and I actually want it to be categorical. I want it to be a factor so that I can use it as a grouping variable when I do my data visualizations, when I do my graphing. So I'm going to go ahead and run this code, see if it works. Looks like it worked. I can do the str command to check if it worked. And so you see now month, instead of being an integer, so before it was an integer, now it's a factor with 5 levels. 5, 6, 7, 8. I assume the next one is 9. So it has 5 levels. So it's no longer sees it as a number. Even though to you and me, it looks just like a number, to this machine, to this software, those are categories. Category 5, category 6, category 7, category 8. A lot of times it doesn't really matter, but in the case of our data visualization software that we're going to use called ggplot, it actually matters. It's like the one time it matters. So I went ahead and converted it. So let's see. So first of all, the first thing I'm going to do is I'm going to plot this data. So I'm going to start with the simple density plot, it looks like. So let me explain this code. So first of all, the ggplot function is from the ggplot2 package that we installed, okay? So remember we loaded the library ggplot2. That's what has this function in it. So I want to do the ggplot function, which is a data visualization function, so it graphs stuff. I want to do it on the data set air quality, and I'm setting my x variable to be temperature. So I want to look at I basically am trying to look and see what's the distribution of temperatures, because I'm using GM density. So if I run this, hopefully it'll make more sense when you can actually see it. But let me sort of make this a little bigger. Okay. All right, so it didn't work. So let's see what happened. So object temperature not found. Air quality equals temperature. So it looks like I had an error, so I have to troubleshoot this. Let me see if a lot of times, you could misspell it. Temp, it's just temp. Why did I put temperature if it's just temp? So you can see up here in the data set, you have this variable called temp. So there's no temperature. I don't know how that worked before when I was trying out this code. Crazy world. So I'm going to run it again. So I'm going to test it. Yeah, so that works. So I'm going to change this to temp, and then I'm going to run it again, see what happens. Okay, so now I plotted out this density plot. So I know in the months, and I assume 5 is May. So you got 5 is May, 6 is June, 7 is July, 8 is August, 9 is September. Okay, so I have May through September. So it's basically 5 spring summery months. So these are the temperatures you can expect. You can see it peaks out at 80. So you have a lot of 80 degree days. And it's kind of distributed around 80. You can see we call this left skewed. So it's more, there's a longer tail on the left side than there is on the right side. So there's not very many 120 days, but you can get some days down to like 50, even in the summer. They're probably not that common, but you can. So you can see you have a longer tail on the left. But other than that, it's fairly normally distributed, which means it's kind of a bell shape distribution. So this in itself might not be that informative, because maybe we're interested in knowing how it differs by month, what to expect in different months, for example. And this is actually an air quality data set, but I'm just using the temperature stuff because I guess I don't really care about air quality. I'm just trying to show you how to do some data analysis. So I'm going to next break it down by month. So that's my next code section. So it's essentially the same thing, but here I need to fix this temperature variable again. It's essentially the same thing, but what I do is I add in, sorry, this code is a little messed up. I got to clean up my code. Okay. So now what I'm doing is I still have my x variable is still temp. So your x variable is going to be the variable down here on your x-axis. It's still temp. But now a difference is I'm going to do a fill that's the month. So there's going to be a different one of these, a different shape, and it's a fill. So it's going to fill in, it's going to color it in, and it's going to be different for every month. And then I can set, well, I don't have to set the alpha. Here, let's try it with and without. So I'll just do it without setting it, and then we'll just run it this way, see what it looks like. See how it all overlaps? So it's kind of messy. You don't really know what's where, but you can look at May. You see May is more down here on the cooler end, and then August is also more drifting towards cooler, on the other end of the summer. But I could actually make that somewhat transparent. So I'm going to do alpha equals 0.4. And then notice I'm not running this stuff down here, the plus and then all this next code. I'm not running that. I'm running it selectively. So I'm going to get to that later. So you can see I selected exactly what I want to run. Run that. And you can see it's transparent. And so I can see how they're all distributed. Look at this huge peak here in 7. That's going to be July. So what the peak means, you might think that means that it's hot, but actually the peak does not necessarily mean that it's hot. It means that it's consistent. So July, you have very consistent temperatures. These flat ones, you have a lot of different temperatures. Like if you're red here, if you're May, it might be 55, good chance it's 50, but it also could be 87. It's unlikely, but it could be. So you have this huge distribution in May. But when you come to July, it's like you pretty much know it's going to be about 83 degrees, right? It's going to be about 83 degrees almost every day. It's very consistent. That's what this huge spike means. All right. So it's still kind of jumbled like this. So what I'm going to do is I'm going to do a facet grid function. So I'm doing this allows me to break it out so that each month has its own like plot, but they're adjacent so that I can still visually kind of compare them. And notice the plus. So after every argument sort of or these are kind of like functions within a function, but they're arguments. So every argument that you add to a ggplot, you have to add a plus before it to get it, see the pluses, to make sure that it reads all those arguments. So I'm going to run this one. Hopefully it'll work. Oh yeah, see? So I'm actually going to make this bigger. Okay. So yeah, it's like I said, here in July, the 7th month, you have this huge spike. So it's going to be 83 degrees every day. I mean, you don't know that because there's temperatures out here, but you're going to get a lot of 83 degrees. Now, when you have this long sloping day like in September, man, you could get anything. It might be 65, it might be 95. It's just different all the time because it's so flat. You see that? That flat distribution versus the peaky one. The peaky one, you have a lot more certainty around what you're going to get. You kind of know, like, wow, July is going to always be like 83. And then, again, here in May. So the consistent thing is the midsummer months have these very peaky sort of averages. So in June, you're here at 77, 83 in July, and then you drop back down to like a peak here at like 79 in August. But then when you look at the late spring, early summer, and early fall, late summer, you get this long flat thing. Okay. So anyway, this is why we visualize data so that we can detect these kinds of patterns that might be useful or interesting for our research. So I'm going to go back to what I was doing. There's actually another thing that you can do. There's a way numerically that I can tell, how peaky versus how spread out these distributions are. And it's called the standard deviation. So I can go back here and get my get my data. All right, go down here. And then I'm gonna get, I'm gonna get some descriptive statistics. So what I can do to this air quality data set is I can group it by month. And then once I have a group by month, I can use the summarize function. And this could be the New Zealand spelling. The author of this package is from New Zealand. So it might have a Z in the US. I don't even know, because I use it so much, it confuses me. But I'm gonna first group it by month, and then I'm gonna summarize it so that I can see what's the mean temperature and the standard deviation around the temperature. Now this na.rm equals true. I added this function in because we have a lot of NAs, but I can't even remember if we have NAs. So let me do the summary function again of air quality and see if we have NAs for temperature. So for temp, we don't have any NAs. But if you do have NAs, like if I was doing the mean for ozone or the mean for solar R, it wouldn't even give me the mean because I have all these NAs. So it would just throw an error. So I don't really actually need this. I could actually just delete this because there's no NAs. So I'm just going to simplify it for you there. Okay, just simplifying it. All right, so I need one more parenthesis. So you always have to close, you have to make sure you have the even number. So there should always be an even number of parentheses and an equal number that face left as those that face right. So I was one short, now I'm good. So if I run this code, I should be able to get a table showing me both what's the average temperature and how variable it is. Okay, so you look here, I do have the average temperatures for each month, and I also have the variability. Interestingly, it's shown, so the standard deviation is the variability. Interestingly, it's showing that I have high variability in September, like I said. So it's 76.9, but it could vary quite a bit. But it's actually, the variability in May is actually not that bad. It is the second highest, but it's not hugely more than July or August. So the standard deviation, so let me do a Google search for, I'm going to do a normal distribution with mean and standard deviation. So I'm just going to show you, hopefully really quick, if I can get a good image of this, what I'm talking about here. All right, so hopefully you can, I'm trying to get this image by itself. All right, I'm gonna zoom in. Okay, so you have the mean, which is the average. And it doesn't always have to be at the peak, but if it's a perfect normal distribution, the mean will be at the peak, as you see here. And you can see like 68.3% of it is within one standard deviation of the mean, either above or below. So that's 68.3% of the data. So if I go over here to the standard deviation, you can see 68% of all my May readings should be between, so 65.5 plus 6. So I'll just do that. 65.5 plus 6. So they should be between 72.35 and 58.65. Okay, so in May, that's going to be like, what was it, 68%, I think we said. Let me check it one more time. 68.3% should be, and this is not exact because your data is never perfectly normally distributed, but it's something like that. We should have 2/3 of our data in between these two numbers. Okay, so if we go back and look at the temp thing, and we look at 58.65, so that's going to be kind of like right here, and 72.35, that's over here. So most of the data is in between these two numbers, all right? So that's the standard deviation. It gives you a measurement of how like variable your data is, how spread out it is. You can see that you have to go further out in September to get kind of like to get 2/3 of the data. You have to go 8.36 degrees in both directions to get 2/3 of to encapsulate 2/3 of the September data. All right, that might be the last. Okay, so yeah, so that was the last thing that I had there. I just want to show you one more thing. If you go to Google and search for RStudio cheat sheets, you can get some really good ones, some really good information about that will help you do better data analysis. Now, the one that would be useful today is the ggplot2 one, so the data visualization. So it's right here. So I'm going to go ahead and show you really quick what we did. See if I can zoom in a little bit. So we did the density plot. Here it is. So we had one continuous variable, which was our temperature. And so we did the geom density plot, and this gives the arguments for it that you can use. So it's helpful. It might not look super meaningful right here, but it is helpful. It also shows you how to do the ggplot command. It gives more information about it over here. This cheat sheet, it's maybe not the best for like learning how to use ggplot, but it's like an incredibly good reference. So the other thing that we used was the geom facet. Geom. Here, let me search for facet. Faceting. So they have a whole section about faceting. Remember when we had those panels, and we did the facet grid. You could do columns. And by panels, I mean, if I go back here, we had 1, 2, 3, 4, 5 different grids, and it was one for each month, right? That's faceting. So again, you can get that information right here in the cheat sheet. So this is RStudio. So we use RStudio software for this class, and they have a great set of cheat sheets. So I encourage you to get those. I actually have them all printed out and stapled up on my wall in my office for when I do data analysis. I don't have them all, but the ones I use the most because they're super helpful as a reference. So that's pretty much all I got today to go through. So I encourage you all to give it a try, see if it works for you. Come to the lab. We'll do a lab and help you kind of walk you through it. For those of you who maybe struggle with it a little bit, my goal is for everybody to be more comfortable with code and data analysis. Even if that's not going to be a big part of your career, at least you can have some familiarity with it. So when you see medical claims or when somebody at work shows you data, you can think about it more intelligently. So that's all I got for today. Thanks for listening, and hope you have a good rest of your day. Thanks. Bye.